How's it going, guys? Today in this video, I want to go over the Module 9 test review. We're going to be going over 1 through 12a in this video. And in the next video, we'll finish up the rest of the review. So on number 1, we're asking you guys to state the transformations on g of x on the parent function f of x equals 1 over x. So that's our parent function, but our general function is going to be f of x equals a times 1 all over 1 over b times x minus h all plus k. So that's our general function, and all those terms, the a, b, h, and k, they're all going to affect the parent function in some way. Okay, so in the first g of x that we see, we have g of x equals 1 all over x minus 5. That minus 5, or rather really the 5, is our h term. So in this case, in this problem, our h is 5, and our h's are going to tell us if we're translating left and right. So if our h is a positive 5, we're going to be translating to the right by 5. The next g of x, we have 1 over x plus 5. Our h here is negative 5. So if our h is negative 5, we're translating to the left by 5. In the next g of x, we have a k value of negative 5. If our k is negative 5, we're translating down or sliding down by 5. Our k terms tell us if we're sliding up or how much we're sliding up and down by. The fourth g of x, we have 1 over x plus 5. Our k is positive 5, so we're sliding up by 5. Next, we have g of x equals 3 times 1 over x. That 3 is our a term. So let's write this out to the side over here. What our a's are going to do is our a's are going to tell us if we're being vertically stretched, vertically compressed, or if we're reflecting over the x-axis. So let's just write this to the side over here. If our absolute value of a, if that's greater than 1, then we have a vertical stretch. And on the next line, if our absolute value of a is less than 1, we're going to have a vertical compression. All right, and we can see on the first one that I haven't answered yet, g of x equals 3 times 1 over x. Our absolute value of that 3 is still a positive 3. That's greater than 1, so we have a vertical stretch. In the next line, we have g of x equals 1 over 3 times 1 over x. Our a term here is 1 over 3, and the absolute value of 1 over 3 is less than 1. So that means we have a vertical compression. Okay? And now in the next line, we have g of x equals negative 4 times 1 over x. So we can see that our a term is negative. And if our a term is negative, that means we have a reflection over the x-axis. So reflect over x-axis. And at the same time, the absolute value of negative 4 is a positive 4, and positive 4 is greater than 1. So that means we have a vertical stretch as well. So your a term can reflect over the x-axis and also stretch the graph at the same time. Next, we have g of x equals negative 0.25 times 1 over x. So our a term is negative again, so that means we have another reflection over the x-axis. So reflect over x-axis, and at the same time, if we take the absolute value of negative 0.25, the absolute value of negative 0.25 is a positive 0.25, and that is positive 0.25 is less than 1, so that means we have a vertical compression as well. Next, we have g of x equals 1 all over 0.25x. So that 0.25 is actually our 1 over b term. So let's write this on the side as well. If the absolute value of 1 over b, if that's less than 1, then we're going to have a vertical stretch. So it's kind of the opposite of your a's. And on the next line, if the absolute value of 1 over b is greater than 1, we're going to have a vertical compression. Okay? So with g of x equals 1 all over 0.25x, that's 0.25. We take the absolute value of it. that's going to be less than 1. So that means we have a vertical stretch. So 1 over b, if the absolute value of 1 over b is less than 1, then you have a vertical stretch. In the next line, we have g of x equals 1 all over 4x. So our 1 over b term is 4. So the absolute value of 1 over b, or your 4, is greater than 1. That means we have a, I'm sorry, I'm not putting vertical stretch and compression. It should be horizontal stretch and compression. Sorry about that. Let me rewrite this over here as well. They both should say horizontal stretch and compression. So 1 over b is less than 1. That's a horizontal stretch. And 1 over b is greater than 1. It's a horizontal compression. There we go. Okay, so it should be horizontal stretch, horizontal compression, and this answer over here for 1 over 4x is a horizontal compression. Okay, so our b term is going to tell you if it's a horizontal stretch, horizontal compression, or if you're reflecting over the y-axis. And we're going to see that in this line over here. We have g of x equals 1 all over negative 0.25x. So if our b is negative, we're reflecting over the y-axis. So we're reflecting over y-axis. And at the same time, the absolute value of negative 0.25 is a positive 0.25, and that term is less than 1. So that means we have a horizontal stretch. In the next line, we have 1 all over negative 4x. So that negative 4x is our 1 over b term. Our 1 over b is negative. So that means we have a reflection over the y-axis again. So reflect over y-axis. And since the absolute value of negative 4 is a positive 4, and positive 4 is greater than 1, we have a horizontal compression. Okay, so that's number 1. So let's go on to number 2. Number 2, on this problem, we're going to decide if the data is inversely or directly related, and we're going to figure out the general equation for the problem, and then we're going to figure out what the missing value is going to be. So I'm going to do 2a and 2b. I'm going to leave 2c and d for you guys to do on your own. We do post a completed key, so you can double check and work with that. So for 2a, before we actually start doing these problems, I want to talk about how we actually figure this out again. So remember, for inverse functions, we know if a function is an inverse, if the product of y times x equals some constant term of a. So you take both your variables and you multiply them for each pair, and they will always equal the same product. You have an inverse. You have an inverse function. Now for a direct function, your y over x, or you should be able to divide one variable, over another variable. You should always get the same a term. Okay? And we're going to see how to actually solve this out in a problem really quickly. And also, remember, your inverse equation should be in the form y equals a over x. And your direct form should be y equals a times x, where a is constant. And that goes for both inverse and direct. So a should always be constant for inverse and direct functions. Okay, so let's go back to 2a, and we're actually going to solve this out. So the very first thing we're going to solve for is we're going to see, do the products of t and c actually equal the same thing for each pair? Okay, so for our first pair, we have when we buy 3 tickets, the total cost is 12. 3 times 12 is 36. And the next, when we buy 7 tickets, the total cost is 28. And 7 times 28 is 196. And 196 isn't the same thing as 36. So that tells me that we cannot be an inverse variation. So we can just cross out inverse because the products are different. So now let's actually check if it's a direct equation either, or if they're directly related. And we do that by just dividing or finding the ratio between the two terms. So I'm going to find the ratio of C over T. So I'm going to divide C by T for each pair and see what I get. So for the first pair, I have 12 and 3. So when 12 is divided by 3, I get 4. When 28 is divided by 3, when 28 is divided by 7, I get 4. 32, we don't know how many tickets we need for that. And when 36 is divided by 9, we also get 4. So the ratio of each pair of terms is always the same no matter which pair we choose. So that means we know that tickets and total costs are directly related. So now that we know they're directly related, we're going to figure out what our function is going to be. So our direct function is y equals a over a times x, or in this case, we're going to use c and t. So I'm going to say c equals a times t. One piece of advice I can give for direct variation problems is that I always like to have my bigger term on the outside, or rather, I like to have the bigger term isolated. Sorry about that. I like to have the term with the higher numbers to be by itself, just so I don't have to deal with fractions as that. All right. So for instance, c has bigger numbers, so I'm gonna leave that by itself on one side of the equation, and I'll have a times t on the other side. Just because you'll see here, if I have c on one side, I'm not going to deal with fractions. So when c equals a times t, we need to figure out what our a is going to be. So I'm going to plug in one pair of points. So let's say 3 and 12. So c is 12, and a is 3. So now I'm going to solve for a. So I'm going to divide by 3 on both sides. And when I do, I get a equals 4. Okay? So my general function will be c equals 4 times t. And now I need to figure out what my missing equation is. So I need to know how many tickets I have when c is 32. So at 32, that's going to equal our a term of 4 times t that we're solving for. So divide by 4 on both sides, and I get that t equals 8. All right, now for 2b. For 2b, we're going to go about it the same way. The very first thing we need to do is see, are we an inverse variation or for a direct variation? So I'm going to check if it's an inverse first. So I'm going to multiply each pair of terms, just s times t, and see what I get. I don't know what my speed is when my time is 80, but when my time is 50, my speed is 12. 50 times 12 is 600. 40 times 50 is also 600. And 20 times 30 is 600 as well. So my product of each pair of points that I know of are all the same. So that tells me that we're going to be an inverse variation. Okay, so the speed and time are inversely related. So if it's inversely related, my function is going to be the one over here at the bottom, y equals a over x. Or for this problem, we're going to do s equals a over t. It doesn't really matter which one you choose, which variable you choose as your y or your x. You can do s equals a over t or put t equals a over s. It doesn't really matter as long as the a is on the top. Okay? So I have s equals a over t, and now I'm going to plug in a pair of points that I know of to solve for my a. So my s, when it's 12, my t equals 50. So when I multiply by 50 on both sides, I get that 600 equals a. So my general function for this problem is s equals 600 all over t. Okay? So from here, I need to figure out what my missing variable is going to be, my missing value. So I need to know what my speed is going to be when my t is 80. So I need to know what my s is going to be when my t is 80. So I'm going to do 600 divided by 80. And if you put that into a calculator or whatever you want, you should get that your missing value should be 7.5. So when you solve this out, you should get 7.5. Okay? And for 2C and 2D, I'm going to leave that for you guys to do on your own. Double check your work with the completed key we'll have online. But for now, let's keep on going to number 3. For number 3, we're asking you guys to find the horizontal asymptote by comparing the degree of the numerator and the denominator. So remember, this is all going to be done or figured out with Bobo, button, eats DC. Remember, Bobo stands for bigger on bottom 0. Button stands for bigger on top none. Each DC stands for exponents are the same, divide coefficients. So for 3a, I have x cubed minus 4 all over x squared plus 2. We're bigger on the top, that's the bottom part. Bigger on top, that means none. We have no horizontal asymptote. For 3b, we have x minus 4 all over 2x minus 5. The exponents are the same, that's each DC. So the exponents are the same. I'm going to divide my coefficients. The coefficient of the top is 1. The leading coefficient of the bottom is 2. So 1 over 2 is just 1/2. So my horizontal asymptote is y equals 1/2. And now for 3c, I have y equals -7 all over 2x minus 36. We're bigger on the bottom, right? -7 has a degree of 0. 2x minus 36 is a degree of 1. So we're bigger on the bottom. So that means my horizontal asymptote is y equals 0. For number 4, we're telling you guys to just get rid of it. Don't do it. We're not really going to be asking anything like it on the test, so don't worry about it. Now to number 5, we really don't have much room at all to solve these out. So I guess what we're going to do, actually I can give myself a little more room, so let's do that instead. I'm just going to do the odd problems here, and I'll leave even ones for you guys to check on your own. Just give me some time to give me a little more room to solve these out on. There we go. So let's start with number 5. Number 5, we're telling you guys that the frequency f of sound varies inversely. That's a key word right there, varies inversely with the wavelength of the upside down y. A sound signal that has a wavelength of 34 meters has a frequency of 10 hertz. And we want to know what the frequency will be of a sound signal of 120 meters has. So let's set up our equation first. We know that f and the wavelength, the upside down y, they're inversely related. So we know that f is going to equal a all over the upside down y. I completely forgot what it's called. So what we're going to do is we're going to plug in our terms that we know, and we're going to figure out what our a is going to be first. Because our a is our constant of variation, so we need to know what that term is. So we know sound signal has a wavelength of 34 meters, has a frequency of 10. So you can plug that in. 10 equals a all over 34, or that a equals 340. So we take that a and put it back into our original equation. So we know our general equation will be f equals 340 all over the upside down y. So now we need to know what the f is going to be when the wavelength is 120 meters. So we want to know what f is going to be when the upside down y is 120. So we're going to divide 340 by 120. And when you do, you get 2.833 repeated. So we're just going to say f is approximately 2.8. Okay, so we're just going to round it to about 2.8. Now let's go on to number 7. Give myself a little more room as well. Okay. So for number 7, we're told the student spends $20 a week for snacks at school if she's present all 5 days. And we're told the total amount that she spends each week varies directly. That word directly is a key word with the number of days of school was in session. If she only spent $12 one week, how many days was she in school? All right, so we know a student spends $20 a week on snacks on school. Let's say the amount that the student spends is S. Okay, and we're going to say that the total amount of days that she's in school is going to be D. So we know that S and D vary directly, so S equals A times D. That's the direct variation equation. The y equals AX, or in this case, S equals A times D. So we know that if the student spends $20 a week on snacks, or with S is 20, then our D, or the amount of days that she was in school for, is 5. So we're going to solve for A. We're going to divide by 5 on both sides, and we get that A equals 4. So we can take that A and put it back into our original equation. So we get that S equals 4 times D. That's our general equation, and what we can use to solve for just about any problem in this context. Okay? So now we're told if she only spent $12 1 week, or if our S is 12, how many days was school in session? So when S is 12, what's D? We're just going to divide by 4, and we get that D equals 3. Okay? Now let's go on to number 9. Number 9, we're told a school club is going on a trip. The price per student of renting a charter bus varies inversely. That's a key word, varies inversely, with the number of students renting it. So it costs $40 per student if 41 students rent the charter bus. About how much will it cost per student if 91 people rent the charter bus? So I'm going to say P is going to equal the price per person, and I'm going to say that the number of people, or the number of students renting the charter bus, is N. So P is the price per student, and N is the total number of students renting the bus. And we know it varies inversely, since that's what they told us. So we know our equation will be P equals A over N. So we're told if the P, or the price per person, is 40, then our N, or the number of students renting it, is 41. So we're going to solve for our A from here. We're going to multiply by 41 on both sides. And when we do, 40 times 41 is 1640. So our A is 1640. So we can plug this A back into our original equation, and we get that P equals 1640 all over N. All right, and now the problem is ultimately asking us how much would it cost per student if 91 people rent the charter bus. So we want to know what the price per person will be if N is 91. So we're going to do P equals 1640 all over 91. And if you solve this out, you get that our P is going to be approximately $18.02 per person. We're just going to kind of round it out, and that's what we get our price per person to be. Just about $18.02. Okay, and for 6, 8, and 10, I'll leave that for you guys to do on your own. You can double check your work with the computer key we have online. Okay, now for number 11 and 12A, we're crossing out 12B. Don't worry with it. Don't worry about it. So let's go on and do 11A and 11B. So for 11A, we're asking you guys to rewrite the function in the form g of x equals a times 1 over x minus h plus k. So to do that, when we're given a polynomial over another polynomial, is we're going to divide the top by the bottom. So we have 3x minus 4, all divided by x minus 1. Do you want to see how many times is x going to 3x? Or in other words, x times what gives you 3x? X times 3 gives you 3x. And now we're going to multiply that 3 with x minus 1. So 3 times x is 3x, and negative 1 times 3 is negative 3. So we're going to subtract the first polynomial with the second one. 3x minus 3x is 0x. Negative 4 minus negative 3 is a negative 1. The 0x goes away, and that negative 1 is our remainder. Okay? So our form of the function is always going to be f of x equals the remainder all over the divisor plus your quotient. Remainder over divisor plus your quotient. So our remainder is negative 1. So our f of x is going to give us negative 1 all over our divisor, or what we divide it with, which is x minus 1, plus our quotient, which is our number up top, plus 3. The only problem here is that we cannot have a negative 1 over the fraction. It has to be a 1. So what we can do is just take the -1 and put it to the front. So we end up getting f of x equals -1 times 1 all over x minus 1 plus 3. Since -1 times 1 over x minus 1 is the same thing as -1 all over x minus 1, we can do that and just pull out the a to the front. All right, I'll leave this up for a quick second before I erase it so we can go over 11b. Okay, so let's go ahead and go over 11b now. For 11b, we're going to do the same thing. We're going to divide the top by the bottom. So we have 3x plus 8, all divided by x plus 2. So we want to see how many times does x go into 3x, or x times what gives you 3x? That's going to be 3. So now we take that 3 and multiply it with the whole x plus 2, and we get 3x plus 6. So now we subtract the first polynomial with the second one. So 3x minus 3x is 0x, and 8 minus 6 is a positive 2. That 0x goes away, we don't have to worry about it, and we're left with the 2. That 2 is our remainder, and if you look at our equation at the top right over here, our f of x is going to be our remainder, which is 2, all over our divisor, or what we divided by, the x plus 2, plus our quotient of 3. The quotient is what's on top. Okay? So that's our function, but the only problem is we can't have an a value in the top. We can't have anything on the top. It has to be 1. So again, we can just pull it out to the front, and we get that f of x is going to equal 2 times 1 over x plus 2 plus 3. Right? Because 2 times 1 over x plus 2 is the same thing as 2 over x plus 2. So that's the answer to 11b. Okay? So let's go over 12a now, the last problem in this video. For 12a, we're asking you guys to rewrite the function in the form 1 all over 1 over b times x minus h plus k. So we're going to go about it the same exact way. We're just going to divide the top by the bottom. So we have 4x minus 7, all divided by negative 2x plus 4. So you want to see how many times does negative 2x go into 4x, or negative 2x times what gives you 4x? That's negative 2. So now we multiply the negative 2 with this negative 2x plus 4. Negative 2 times negative 2x plus 4 gives us a 4x minus 8. And we're going to subtract the top with the bottom. So 4x minus 4x is 0x. Negative 7 minus a negative 8 is the same thing as negative 7 plus positive 8, or just a positive 1. That 0x goes away, and negative 2x does not go into 1, so that 1 is our remainder. So we're going to put it into that same form we talked about earlier. The f of x equals our remainder, which is 1, all over our divisor, which is what we divided by, the negative 2x plus 4, plus our quotient that we got up here of negative 2, so it should be minus 2, not a plus sign. All that minus 2. Okay? So the only problem here now is that if we compare what we have here in f of x with this g of x over here, we don't have a coefficient in front of the x on the bottom, right? Looking at the bottom right here, the denominator, we can see that we don't have a coefficient in front of the x. So that means we have to take out that negative 2 in front of the x to make sure that our coefficient of x stays 1. So when we take out that negative 2 in front of the x, we're going to divide everything that's left over by the negative 2. So negative 2x divided by negative 2 is just a 1, and 4 divided by negative 2 is negative 2. So we just pulled out that negative 2, and that's what we're left with. And now this is actually in the form that we want. So that is going to be our answer. Okay? Hopefully this video helped, guys. Like I said, in the next video, we're going to be going over the rest of the packets.